Once upon a time, in a faraway land, lived a royal family in a royal castle.
Mom, so I was at royal school today and we were talking about birthdays, but I don't know mine.
Honey, it's time for me and your father to tell you.
Tell me what?
Phil, get in here.
Do you guys not know my birthday? Do you not care about me?
So sorry that we don't know your birthday. When you were born, we made a compromise. You were a very sick baby, and we called your fairy godmother to help. She said that there was only one way. Either I fix your baby and you don't remember the date of her birthday, or your baby may suffer.
Fairy godmother, are you here?
Are you the Annabella? Are you the one that I saved when you were, well, how much do you know about me?
Well, I know that you sacrificed my parents' memory of the day I was born for my life. Thanks for that, by the way.
No problem. I presume that you are here to find out how old you are. Am I right?
Yes. You see, in school we were talking about our birthdays, and the thing is, I don't know mine.
Okay, I can help you. For you to know how old you are, you must solve it yourself with a system of equations. The first thing you need to do is define your variables. How about we use x and y? X will be your age now, and y will equal your mother's age now.
Learning about this in Royal Math class. Don't we set up equations with those variables?
Exactly. You can try, but make sure that you write your equations in slope-intercept form.
Okay, so I know that my mom was 26 years old when she had me, so one of the first equations could be y equals x plus 26, because that would tell me how old my mom is, although we are not looking for that answer. Then my second equation would be y equals 3x minus 6, because we know that she is 6 years less than 3 times older than me.
Good job. Now we're going to use a method called substitution. Substitution is where we use two equations, and with one of them we enter it into the other.
Okay, so since y equals x plus 26, and y also equals 3x minus 6, then x plus 26 equals 3x minus 6. The next thing I'm going to do is combine my like terms onto their own sides to get the variable on its own. First, I'm going to add 6 to both sides and get x plus 32 equals 3x. Then I'm going to subtract x from both sides and get 32 equals 2x. I'll divide both sides by 2 now and get that x equals 16. If x equals my age now, then right now I'm 16 years old.
I knew you could do it. Now head on home and your parents will surely remember the day you were born.
We are so proud of you. Now we can clearly remember how old you are. Your birthday's June 27th, 1999, and you're 16.
Hey, that's today.
Yeah, this calls for a celebration.
I did not know how old I was, so my fairy godmother they called. We did some math on our own, that darn curse leaves us alone, because now I know my age, I'm 16. I used y equals x plus 26, as well as 3x minus 6. Since y equals those, then we will substitute both. X plus 26 is 3x minus 6.
She's 16.
I'm 16.
She's 16.
Systems of equations you've seen.
We use slope intercept to solve this something left. And we know that Annabella is 16.
Then I combined all of the like terms and got the variable alone. To both sides I added 6, subtracted x, there were no tricks, so then I got 32 equals 2x. To get x all by itself, now I have to simplify. I'll divide it all by 2, dividing is nothing new. I know my age now cause x equals 16.
She's 16.
I'm 16.
She's 16.
Systems of equations you've seen.
We use slope intercept to solve this nothing left. But we know that Annabella is 16.